Alright, my little math friends, we're moving on to the next part of our book, which is going to deal with geometry. And maybe you guys will like geometry because geometry gives you a visual of what's going on. So some people like that a little more because it helps them to see what's happening when they're working out the math. So you may find that as you go through different parts of this book, you like different sections more because it's easier for you, because everyone's brains works a little differently. Okay, so it's kind of neat to see that process as we go through this. Our first part of our geometry part of the book is using scale and scale drawing. So let's talk about what is a scale and what is a scale drawing. Okay, a scale shows how many times smaller or larger a model of an object is compared to its actual size. Okay, so this could be a drawing of a building, or maybe even like a model of a building made from clay or some sort of material or a 3D printer. So it's an actual, like, it's a model of something that is of its actual size, and it can be a smaller model or it can be a larger model. Okay, one of the two. What we're going to be working with is a scale drawing. A scale drawing represents the actual size of the object, but on a smaller or larger scale. Okay, so the drawing can actually be bigger than the real thing or smaller than the real thing, but it has to represent the size of the actual object. Okay, here's the key idea with this. Using a scale is more than just making or drawing a small picture. Alright, for example, if you're an engineer or an architect and you're drawing a picture of a building that you want built, it's more than just drawing like a picture of the building on paper. Okay? The scale needs to represent an object's actual size. Okay, so for example, however long this wall is going to be compared to this wall, it needs to be the exact same actual sizes, just on a smaller version on paper. And what an engineer or an architect will do, they will tell you how long each of these walls are compared to the original. Like, for example, they might say 1 inch of this wall on paper comes out to 10 feet of the actual wall itself. So 1 inch is equal to the 10 feet of the actual wall. And that is helpful because the people building this building for the engineer, the contractors and the other builders need to know this, because when they look at this drawing, and if this wall here is 8 inches long on the drawing, they know that 1 inch is equal to 10 foot, so 8 inches times 10 would be 80 feet. They would know to build that wall 80 feet long. Okay, that's why it's important to show it's representative of the actual size. Here's our first example. I have a nice model car for you. I'm sorry that your picture cannot be in color there. You can print it off at home if you really want some colored notes. But here's the actual size of our car: 5 feet long by 8 feet, or 5 feet wide by 8 feet long. Okay, then we have a model image of the car, and our model is 5 inches wide by 8 inches long. Okay, this model is representative of the actual size of the car, like the mirrors, the headlights, the wheels, everything is exactly the same as the real car, it's just on a smaller model. Okay, and if we wanted to identify what the scale is used in this drawing of the car, well, since 5 inches here represents 5 feet there, we could say this drawing is 1 inch on the drawing is equal to 1 foot of the actual car. Okay, that would be the scale model that would represent this car. Alright, let's get into actually using some scale model to answer some math questions that I'm going to give you guys. Here is our first one. A drawing of a rectangular building has a scale factor of 1 inch is equal to 25 inches. Okay, so the drawing is 1 inch. The actual building is going to be 25 inches. That's how much is represented. If the building dimensions on the drawing are 15 inches by 26 inches, what is the size of the actual building? Okay, we want to find out what the actual building size is if the picture is 15 inches by 26 inches. Okay, here's all we have to do. Since 1 inch equals 25 inches on the building, and if I have 15 inches on paper, we're going to go 15 times 25 to get the actual size of that first wall, and that is going to be 375 inches. Okay, 15 times 25 is going to be 375 inches. Now, same thing with the next one. 25 inches on the paper. I'm going to multiply that by 25 inches of our scale, and that will give me 650 inches. Okay, that is the size of the actual building, 375 inches by 650 inches. Okay, now let's get into something that's going to be a little bit more complicated. We just have a couple steps that we have to work out. Here is our problem here. Again, I'm sorry you don't have nice colored rainbow looking fish on your paper, but you'll just have to work with the black and white ones and enjoy my nice colored fish I have up here. Okay, the art class is planning to paint a mural on an outside wall. This figure is a scale drawing of the wall. What is the area of the actual wall? Okay, that's what we need to find out. Alright, take a look at this. Here is our scale. 2 inches of the drawing is equal to 3 feet of the actual wall itself. Okay, so every 2 inches of this drawing is going to be 3 feet of the actual wall. That is the scale factor we're using. Since we're not dealing with 1 to 25, like 1 inch equals 25 feet, because we got 2 inches here, we got a couple different steps to do since this number is not 1. Okay, the first step that we need to do is we need to divide the SD. Okay, let me tell you what the SD is. Okay, take a look at this. Here we have the scale drawing is 2 inches. That's going to be my SD. And over here we have the size of the actual wall, so that is going to be the scale actual. Okay, so this is our scale drawing. This is the size of our scale drawing, and it matches up with what our scale drawing is here. And then we have the scale actual, the actual size of the wall. So what we're going to do is we need to divide the scale drawing. Alright, so we need to take this 2 inches of our scale here and divide it into the scale drawing to find out how many times 2 inches is going to go into this side of the scale drawing. When we do that, 28 inches divided by 2 inches is going to get you 14 inches. Okay, that's how many 2-inch pieces we have going into that 28 inches of the drawing. Alright, then we need to multiply by the scale actual. Okay, now that we divided that out, we're going to multiply this 14 by the 3 feet, and that's going to tell us how long the wall is. When we do that, that is going to get us 42 feet. Alright, that is how long this actual wall is going to be. It's 42 feet is this actual size. Alright, now let's do those same exact steps, and we're going to find out how long this wall is going to be in real life. Alright, let's take our SD, divide it by the SD. We want to find out how many times 2 inches will go into the 11 inches. That is going to be 5.5 when we divide 11 by 2. Now we're going to take that amount and we're going to multiply it by the 3 feet. And when we do that, we are going to get 16.5 feet. Okay, so the actual size of our wall is 42 feet by 16.5 feet. But we're not done yet, because the question says what is the area of the actual wall. So now we just need to go length times width to get our area. And when we do that, we come up with 693 square feet when we multiply the length and the width. Okay, so that is the actual area of the actual wall. Okay, let's take a look at another problem, and we'll work this one out together. This time, the drawing plan for an art studio shows a rectangle that is 13.2 inches by 6 inches. Okay, that's the actual drawing of it. The scale on the plan is 3 inches is equal to 5 feet of its actual size. Okay, every 3 inches on the drawing is going to be 5 feet in real life. Find the length and width of the actual studio. then find the area of the actual studio. Okay, we need to find the length and width, then we're going to find the area. We're going to use the same exact steps like we did above because we do not have a nice simple scale like 1 inch equals 5 feet. We have 3 inches equals 5 feet. So we have to do our 2 extra steps like we did up above. First, we're going to divide our SD, okay, our scale drawings. So here's the scale drawing, and then here's the one side of the scale drawing up here. Here's the other side of the scale drawing over here, and then this side is our scale actual, the actual size of the building. Okay, so we're going to take 13.2, we're going to divide that by 3, and when we take 13.2 and we divide it by 3, we are going to get 4.4. Alright, now we're going to do step number 2. We're going to multiply that answer we got by the scale actual. So we're going to take this 4.4, multiply it by the 5 feet, and that'll tell us how long the actual wall is. So this side of the studio is going to be 22 feet. Now let's find out how long the other side of the studio is going to be. We're going to go back to step number 1, take 3 inches, divide that into the 6 inches. That's going to give us 2. Now we're just going to go step number 2. 2 times the 5 feet is going to give me 10 feet. Alright, so that is our dimensions of the building. 22 feet by 10 feet is the size of the art studio. Now we just need to find the area, length times width. When we do that, that gives us 220 square feet. Okay, so that is going to be the area of the actual studio. Alright, let's see how you guys do on solving one on your own. Okay, take a look at this. I got to try this problem for you. See if you can go through those same steps we did and come up with finding the area of the actual room. Alright, then hit play and we'll see how you guys